One of our goals in this lesson is to identify the points on the unit circle corresponding to all of our special angles. We already know how to talk about a point by considering the length of the arc to get to that point, but now we also want to be able to talk about a point by identifying the x, y coordinate point that goes along with it. A few of these will be easy to do, specifically the ones that are on an axis, like this point over here at the angle 0 or 2 pi. Well, if this is a unit circle and so this radius is 1, that means that I have gone over 1 and up 0 to get to this point. So I would have the coordinate 1, 0. Similarly, to get to pi, I must go back 1 and up none. So my coordinate is going to be -1, 0. To get to the angle pi halves on the unit circle, I'm going to go over none, but I'm going to go up 1, which gives me a coordinate of 0, 1. And to get down to 3 pi over 2, I need to go over none and down 1, so that's going to be 0, -1. And just like that, we already have the coordinates of 4 points on our unit circle. The next point I want to try to figure out is the point that goes with pi thirds. And I'm not sure exactly what those points are, but I can maybe approximate them. This point here would represent my x distance, and over here would be the y coordinate, or that y distance is my y coordinate. And I can maybe approximate those. It looks like my x is maybe about 0.5, and my y distance is, well, if this is 1 up here, maybe that y distance is like 0.8. I'm going to tell you today that 0.5 is exactly the right answer. We can show that maybe later on, but in fact, I'm going to write it as a fraction, that the x coordinate, this distance here, is exactly 1/2. But I'm not quite sure what that y value is, but we can figure it out using the equation x squared plus y squared equals 0. Let's do that. So the point corresponding to pi thirds has the x coordinate 1/2 and some y coordinate. I'm not really sure what it is, but I know that this point better be on the unit circle. So I know that x squared plus y squared is equal to 1. And if I plug in the x value of 1/2 into this, I now have an equation that I can solve for y. 1/2 squared is 1/4. Then I might subtract the 1/4 on both sides. We have to be really careful here about subtracting fractions. We'll have to remember that 1 is the same thing as 4/4. So when I subtract these, I actually get 3/4. So I have y squared equals 3/4. The last thing that I'll do is take the square root and say that y is, let's see, the square root of 3/4 is the same thing as the square root of 3 over the square root of 4, which is the same thing as the square root of 3 over 2. Now, technically, remember when we take a square root, we need a plus or a minus. But I'm going to keep it with just the plus one because I know this y value here is positive. It is above my axis, so it's a positive value. So I want the positive root 3. So I can go ahead and fill that in and say that my y value here better be root 3 over 2. Let's try the same thing with pi over 6. Pi over 6 has an x value of maybe 0.8 or 0.9 and a y value of, actually, it looks like 1/2. I think that we also go through the 0.1/2 here. So I don't know exactly what my x value is, but my y value will be 1/2. Because I know that, I can use the same process to figure out the x value for pi over 6, just like I did to find the y value for pi over 3. What do I mean by that? Well, I know that the point better be some x value with a y value of 1/2. And this point will satisfy the equation x squared plus y squared equals 1. If I fill in what I know, I have x squared plus 1/2 squared equals 1. I can square the 1/2 and say x squared plus 1/4 is 1. Subtracting the 1/4 gives me x squared equals 3/4. And then when I take the square root, I get x equals the square root of 3 over 2. So pi over 6 corresponds to the point root 3 over 2, 1/2. All right, let's try this one more time to see if we can find the point that corresponds with the angle pi over 4. If I try to estimate it, it looks like the x coordinate for pi over 4 is maybe like 0.6 or 0.7. It's a little bit more than 1/2. And it looks like the y value there is also about 0.6 or 0.7. I don't know exactly what the value is there, but one thing that I notice here is I think that this distance, my y distance, is the same as my x distance here. Right? This looks kind of like a square, so the side lengths would be the same. So while I don't exactly know what those points are, I can at least say that maybe it goes to the point x comma x, because the x and y values are the same. So when I take this equation, x squared plus y squared equals 1, I can go ahead and replace y with x, because x and y are the same. X and y are the same at this point, pi over 4. So x squared plus x squared equals 1. Well, that's 2x squared. And now I have an equation for just x that I can solve. I can divide by 2 and then take the square root, giving me the square root of 1, or 1 over the square root of 2. All right, this is a fine answer here to say that maybe we go through the point 1 over the square root of 2, comma, 1 over the square root of 2. But I am going to do one more thing to make this answer look a little bit nicer, called rationalizing the denominator. In general, rationalizing the denominator is not something that I care that you do that much. But because these are really, really common points that are talked about all the time, there tends to be one specific way that these points are written down, and it's with a denominator that's rationalized. So I'm going to go and do that so that visually when you see other unit circles, it looks the same. So when we rationalize the denominator, what we'll do is we actually multiply and divide by my denominator here. That doesn't actually change my number itself, it just changes the way it looks because I'm multiplying and dividing in the same step. I'm undoing what I'm doing right away. But if I kind of multiply across the top and across the bottom here, now I have the square root of 2 over the square root of 4, or root 2 over 2. That's the way that this point is usually written down. It's normally written as root 2 over 2, comma, root 2 over 2. And if you check that in the calculator, the square root of 2 divided by 2 is about 0.707. So our estimate of about 6.6 or 0.7 was a really good estimate. Let's fill that in. We now know the points that correspond to all angles in the first quadrant of my unit circle. The first quadrant being this area up here. We can now use that information actually to get all of my other special angles using symmetry. Let me tell you more about what I mean by that. Let's think about the point 2 pi thirds. 2 pi thirds has some sort of x distance and also some sort of y distance. And it looks like the y distance here is actually the same as what we had for pi thirds. And I think that the x distance here looks a lot like a half, but since we're going to the left, we would call that negative a half. In fact, we can kind of use the symmetry that the point here is going to be almost the same as this point, except the x value is the opposite. I would say that 2 pi over 3 corresponds to the point negative a half, and then up root 3 over 2. So we can use the symmetry of this circle to figure out those values. Similarly, to get to the angle 3 pi over 4, I'm going to go left root 2 over 2 and then up root 2 over 2, giving me a point of negative root 2 over 2, comma, root 2 over 2. We'll have a really similar story for 5 pi over 6. To get to 5 pi over 6, it's a lot like how we got to pi over 6, but instead of going right root 3 over 2, I'm going to go left root 3 over 2, giving me a point of negative root 3 over 2, comma, 1/2. And now we have all the angles in my second quadrant. I'm going to skip all the way up to my fourth quadrant next and think about what's going on there. Just like how we got the angles in quadrant 2, I'm going to use the information from quadrant 1 to help me figure out the angles in quadrant 4 using symmetry. So 11 pi over 6 is a lot like the point pi over 6, except for to get there, instead of going over and then up, we're going to go over and then down, which tells me that my coordinate is going to be still that over root 3 over 2, but down a half. To get to 7 pi over 4, I'm going to go right and then down. But because of the symmetry that I see with this point pi over 4, I know that my point is going to be root 2 over 2, comma, negative root 2 over 2. What do you think the point for 5 pi over 3 would be? Use the point from pi over 3 to figure that out. Let's see, did you do 1/2, comma, negative root 3 over 2? All right, we have one more quadrant to go. Let's think about our points in the third quadrant. To get to 7 pi over 6, I need to go left and then down, which is a lot like how I got to 5 pi over 6, which was left and then up, but now I'm going left and then down. So I think my x-coordinate is going to still be negative root 3 over 2, But now my y value, I need to go down, so my y value is going to be negative a half. For 5 pi over 4, I'm going to have negative root 2 over 2 and then negative root 2 over 2 because I need to go left that amount and then down that amount. And 4 pi over 3 is going to be negative a half, negative root 3 over 2. So we have now filled out our unit circle for all of our special angles. We did that by first figuring out the points for quadrant 1 and then using symmetry and reflection to figure out the points in quadrants 2, 3, and 4. You should work to be able to memorize this unit circle. But when I say memorize, I really mean memorize quadrant 1 and then get familiar with how to use the information in quadrant 1 to fill out the information in the other quadrants. I'll tell you one more trick before we go. Oftentimes, students get confused about the point at pi over 3 and pi over 6 because the x and the y values are really similar there. They're just switched. What I'll remind you is that root 3 over 2 is about 0.86. To get to pi over 6, I know I need to go over a lot and up a little bit. So that tells me that my x-coordinate must be bigger than my y value because I need to go over a lot more than I need to go up. And that's what tells me that root 3 over 2 better be my x-coordinate because that one's bigger. Conversely, to get to the point pi over 3, I need to go over some, but then up a whole lot. So since my up is a lot bigger, that tells me that my y value needs to be the bigger number, meaning that root 3 over 2 is the y value. There's all sorts of other tricks you can use to be able to memorize these, a lot of mnemonic devices. So go ahead and do some Googling, search around, and see what is your favorite mnemonic device to remember these. Or create your own.